Right. Ready. So good evening all of you. So the summary of the last lecture we have discussed this photoelectric effect. So finally what did you understand from this photoelectric effect? So whenever the photon is striking the metal plate, behaves like a particle but distribution like a wave, while hitting like a particle but a distribution is like a wave. So that's why whenever intensity is increased, amplitude is increasing and more number of electrons are emitted. That is because of maybe the second point maybe you didn't understand clearly. So what I said yesterday, after the hitting, that means it is distributing like a wave. Whenever you are talking about a wave, there will be more amplitude, there will be less amplitude and more spreading will be there. For example, if you see, take a laser light, laser beam. If you focus like this, there is a small dot. Am I right? So if you take some more focus light or something like that, more intensity, then what will happen? Its spreading is more. If you take less intensity, spreading is less, something like that. So because of that distribution, we are able to get more number of electrons whenever the intensity is increased. This is what we have discussed. Am I right? Now ready. Okay, so here in the last class what we have discussed, one more time, photoelectric effect. So conclusion. Now for example, here I have some, what do you say, what is this tube called? Discharge tube. Okay, fine. So now let us suppose here there is a metal plate. Whatever you are using, that zinc, copper, sodium, whatever some metal is there. Okay. And here another electrode is there. Okay. So here we have given some potential difference. Now carefully observe. Right. Now let us suppose this is our target. This is our target. So that's why our light is falling on this metal surface. Okay. Like this. So that is the light, photon, whatever it is, of a frequency nu. Then what is happening here? Electrons are ejected. Say yes or no? Yes, sir. And these electrons will be collected by here collector. So we can say this is just like an emitter and this is like a collector, right? So these electrons will be collected by this and we are getting the current. This is what is photoelectric effect. If you see that solar panels and all these things, this is what happened. Okay. Now the question is, what terminal I have to take this and what terminal I have to take here? Which one? C is a positive. Oh, if electrons is collected by the positive electrode. If you are accepting electrons, you will become a positive or negative? Okay. What you are saying is you want to take it as a positive, right? Okay. If you take this positive and this is the negative, let us suppose. Now what is the electric field direction? Positive to negative. Electric field is always from diverging from positive, converging at a negative. So that is electric lines of force. Electric lines of force, closed lines are, not closed lines are. Electric field lines, closed or not closed? Not closed. Whose curl is 0? What is the meaning of curl? Circulation. No circulation. No circulation means what? Not closed loops. So because electrostatic field is a conservative field. Electrostatic field is conservative. So this is the electrostatic field. Right. Okay. So this is the electric field direction. Generally, if electric field is like this, positive charged particles are always accelerated in the direction of electric field. Negative charged particles are always opposite to the electric field. I hope you know this. If you don't know, come to this. Now for example, here we have electric field and here is a charged particle Q. What is the force acting on this charged particle? Go slowly, Babu. No need to get tension. What is the force acting on a charged particle? QE. Q for charge, E for electric field. Now, for example, if I take a Q is a positive, then what is this F bar ma? F bar is equal to plus QE bar. Now tell me, what is this plus indicates? Force, field both are in the same direction. Because your charge is a positive, force acting on the positive charged particle is always in the direction of electric field. That's the meaning. If I take a Q is a negative, so could you please tell me what is the F bar here? Minus QE bar. Now tell me what is this minus indicates? This side vector, that side vector, you have a negative sign. Means what? Both the vectors are in opposite direction. Now tell me, force on the negative charge is? That's it. Opposite to field, and here plus indicates in the direction of field. If you know, okay. If you don't know, so please learn. So for example, if I am a charged particle, I am here, I am a positive charge, electric field is like this. Then what I will do, what electric field will do? It will take me in the direction of a field. Say yes or no? Yes. If I am the negative charged particle, then what electric field will do? Opposite. Now tell me, your electrons are moving in which direction? Opposite to? So that means electrons will move like this or not? Then where is the photoelectric effect? If you want to observe the photoelectric effect, it should be negative charge, not positive charge. So if you give the positive charge, electrons will be attracted by the positive charge, positive plate na. So that's why here this is not a positive. I don't know who told you. In the photoelectric effect, what we are having? Negative charge. Very important. So here, listen carefully. This is the negative and positive, of course. You can take like this. So I am taking this as a V. Actually, what is this? Vs. I will tell you what is that Vs. So finally, this is a negative and this is a positive. Now leave this. So what is the meaning of this negative? So finally, here we got a negative potential. What is that? We can take it as minus how much amma? Vs. Now observe carefully. So here we have a metal plate and this is the light falls on the metal plate, right? So once the light falls on the plate immediately, are you getting the electrons? No. For that what we need? Sufficient energy. Say yes or no? That means if you have this metal plate and if you are sending a light of certain frequency, then only electrons will be emitted. Say yes or no? Yes, why? Because for every metal there is some bound energy or binding energy. The electron is already bound to the metal. Say yes or no? Yes. For example, if you are there, you are already bound to that state. If we want to remove you from that bench, how much energy we have to spend? That much energy. Simple example, hydrogen atom. What is the ground state energy? Minus 13.6 eV. What is the meaning of minus 13.6 eV? If you supply 13.6 eV energy, then only it will become. So, whenever you are already in the one state, if we want to remove you from that state, we have to supply that much energy. So already the, are you listening? Already electron is bound to the metal surface. Okay, it is not on the surface. Light, please come, I will come. No, it's not like that. So it's not on the surface, it is bound to the metal. Clear? If you want to remove that electron from the metal, first you need to supply minimum amount of energy. That is called work function. So every target is having work function. I am representing work function as a phi. Some people will represent it as a W. So I hope now you understand first point, what is meant by work function. Because electron is already bound to the metal. If we want to remove the electron, you need to supply minimum amount of energy. That minimum amount of energy is nothing but work function. So what is the definition of work function? The minimum amount of energy required to remove the electron from the metal metal surface is called. Everybody clear? Good. So we have defined one thing, work function. The minimum amount of energy required. Come on, say. To remove an electron from metal surface. From the metal surface is nothing but work function. So once if you send the light, immediately electrons won't come. Okay, we need to supply some minimum amount of energy. That minimum amount of energy is nothing but work function. Right. Any settings any custom. Right. Okay. That's it. So I hope everybody understand what is the first definition, work function. And this is the setup of so why we can't take a positive charge means here, if you take the polarity positive, electrons will directly move towards that. Okay. So if the electrons has to overcome from certain potential, okay, so that I will explain what is that. First everybody understand what is meant by work function? First, right. And this is also very important, please remember. A positive charged particle always move in the direction of field and a negative charge always opposite to the field. No, we won't send any PDF files. No, no. Actually, these many years, why we didn't conduct the classes means because of this. If we send the files, you will spread it in the post office, telegram. Whenever you send certain frequency, and that certain frequency will be decided by which one? Target. So different targets, different minimum, different work functions. Good. So work function is a completely property of target. Ready? Right. So whenever you are sending this light must have some minimum amount of energy. That minimum amount of energy will be decided by the target, and that property is called work function. The minimum amount of energy required to remove the electron from the metal surface. Good. Right. Now listen. So I am taking this work function here. Right. So you can write either phi or w anything. Can you please tell me what is this work function formula? H nu naught. And what is this H nu naught? Is nothing but Hc by lambda, where nu naught is called threshold frequency. Threshold frequency. Threshold frequency. And this lambda naught is nothing but a threshold wavelength. Threshold wavelength. Right. So what is this threshold frequency or threshold wavelength? Threshold frequency, minimum frequency. Threshold wavelength, maximum wavelength. At the denominator, that is in the numerator. If this is a minimum, this is a maximum. Right. Okay. Next. Next point. Now, from the beginning onwards, we are saying something photon, something like that. So, if this is the photon, can anybody tell me what is the energy of the photon? H in. So, which is nothing but what? Hc by lambda. And Hc value 12,400 eV angstrom by lambda in angstroms. So 12,400 eV angstrom by lambda in angstrom. Sometimes we will use this 1240 electron volts in nanometers. Then lambda is also in a nanometers. Remember always, whenever they have given lambda in terms of angstroms, please use 12,400. If they have given nanometers, then use 1240. So what is the energy of photon? 12,400 by lambda in, or 1240 by lambda in. But answer is in terms of electron volt. Wait, I want to ask one question. For example, I have taken visible light. Can anybody tell me visible light range is from where to where, wavelength? 400 nanometers to 700. Okay, 400 nanometers to 700 nanometers. So here the wavelength is given in terms of nanometers. Then I would like to find the energy. So that is 1240 by 400 electron volts to 1240 by 700. Nanometer gets cancelled. Here what you are having? So this is a cancel. Now could you please tell me how much here? 3.1. EV2, I think this is a 1.7. Check. 7 ones are? Oh, super. Right, anyhow. So now tell me, your visible light from where to where? VGR, violet to red. The energy range is from where to where? So this violet is 3.1 and this red is 1.7. Okay. Now one more thing I want to ask. Now for example, there is an electron. Okay. Sorry, not electron. I'm sorry. I'm taking lambda. Lambda is a 0.0242 angstroms. How much? 0.0242 angstrom. If I want to find the energy, what I have to do? Hc by lambda. Tell me. EV. How much? Okay, we'll take it as a question, right? Leave it. So that's it. And finally, here what I explained, work function definition. So this also can be written as what, ma? This is also nothing but 12,400 by lambda naught. But it is in, right? So next after that, photon energy equal to h nu, which is nothing but hc by lambda. 12,400 by lambda in angstroms, 1240 by lambda in next. This is the visible region range 400 to 700. And here I will give you the problem. Let us see how many of you will do. Come on. Today there is no second board. It's gone. That's why today it was late. So finally, what do you understand? Less wavelength, more energy, more wavelength, less energy. So this is the less wavelength, more energy, and more wavelength, less energy. Right, write the problem. Consider a photon of wavelength. Consider a photon of wavelength. It's a very important concept. This question related to one important concept. Consider a photon of wavelength lambda equal to 0.0242 angstroms. 0.0242 angstroms. Find its energy. Find its energy and discuss. Discuss about the answer. So you are getting some different answer and we have to see what is that answer. First you please do that mathematics. So here they have given photon of wavelength. Slowly. You think this is your first question. 0.0242 angstroms. I request you find the energy. No calculators, nothing. Hc by lambda. If lambda is given in angstroms, use a Hc value 12,400. Without calculator, please try to cancel. It's impossible, huh? Okay, try calculator. Do you have calculator? Oh. Huh? 0.5. 12,400 by 0.0242. Okay, tell me. 5, 1, 2, 3, 9. Oh. 5, 1, 2, 3, 9, 6. Point something, huh? Okay. Leave it. This much you got around. Okay. Shall I write like this? Shall I? Now tell me, what is the energy answer? Come on. What is this 0.51 MeV? Have you seen this anywhere? In this question you have seen. Have you seen this anywhere? Energy E equal to 0.51 MeV. Have you seen this value anywhere? No. Till now. Sure. Pakka. Next. Have you seen this? That's why I told you discuss. No, you also not seen. Maybe you have seen. You didn't remember. Oh. Okay. If we see a movie, will you remember faces, dialogues, songs? Next, have you seen? ఏంటా 511 keV? ఎవరి ఎనర్జీ? హూజ్ ఎనర్జీ? So which energy it is? Electron rest mass energy. Good. So actually here, whenever you have an electron, it's a rest mass. E equal to how much? mc square. What is the mass of electron? 9.1 into 10 to 9.1 into 10 to the power of minus 31 kg. If you take it and substitute, you will get 0.51 around MeV or 511 keV. 0.51 MeV. Now tell me, the wavelength, photon wavelength, how much you have taken? 0.0242. Listen. 0.0242 angstroms wavelength corresponding to 0.0242 wavelength of a photon corresponding to energy of rest mass. Now next question. Have you seen this value anywhere? Maybe you have seen, you didn't remember. No one. No one has seen in the class. Compton wavelength. What is that? Compton wavelength. This is the special wavelength called Compton wavelength. Compton wavelength of course, 0.0242 electron. 0.0242. See, what I am saying is, this is the Compton wavelength of the electron. That means the photon strikes the electron, you will get the Compton shift. I will explain tomorrow, day after tomorrow. There you will get the Compton shift. From that we will get the Compton wavelength. That Compton wavelength lambda c is 0.0242 angstrom. Photon is having that wavelength, its energy is equal to electron energy. See, the concepts are different concepts, but all are coming to one place. That means what I am saying is, in Compton effect, if you use this target and if you are sending the electron, there you will get the Compton shift as this lambda. Now if you take a photon with this lambda, you are getting back to energy of electron. That's why there is a beautiful question. What is that? The energy corresponds to Compton wavelength of the electron. The energy corresponds to Compton wavelength of the electron. Its rest mass energy. So, if the photon is having a wavelength equal to Compton wavelength, then the energy is equal to rest mass energy of electron. That's the point. Okay, come on. See, doing problem means not simply doing the mathematics and closing. We have to analyze what is the result we got. So why these things are happening, and maybe tomorrow we'll understand while I'm explaining Compton effect. This is the rest mass energy of photon. Interma. The wavelength corresponding to rest mass energy of electron is Compton wavelength, lambda c. That's why although photon is having a Compton wavelength, so energy is equal to electron's energy. Over? Right. Now ready. Okay, so here we are giving the photoelectric effect equation. So finally, photoelectric effect equation. Anybody tell me what is this photoelectric effect equation? What is photoelectric effect equation? Law of conservation of energy. So nothing but law of conservation of energy. Now see. Okay, so this is the metal and we have some electrons here, and this metal surface is having some work function, already we have discussed. Okay, right, now here you are sending this light with the frequency nu, then what is the energy? Then the electrons are ejected, already we have discussed all these things, and they ejected with some kinetic energy K. Now according to this law of conservation of energy, all of you see, how much you are sending? H in. How much is the spending? What is the remaining? So remaining equal to sending. So kinetic energy of electron equal to H nu minus phi. So this is nothing but H nu minus H nu naught. Now this is the kinetic energy of the electron. Is it maximum or minimum? Maximum energy or minimum energy? Maximum energy. Now what is this H nu in terms of lambda? You are not focusing. Hc by lambda, and this is also Hc by lambda. So that's it. The kinetic energy, this is the maximum possible kinetic energy, because you are sending how much? H nu. For example, you are sending 5 electron volts. Let us say this is the 2 electron volts. Then what is the kinetic energy? You won't get more than 3 electron volts. Say yes or no? If you get more than 3 electron volts, what is violating? That's why photoelectric effect equation is nothing but law of conservation of energy. That's why you won't get more than this kinetic energy. So that's why it is. Then what is minimum kinetic energy? Next. Maximum is this one. Then what is the minimum? Next. Next. You understand why it is maximum? This is the maximum. Okay. Maximum kinetic energy of the electron is nothing but sending minus spending, which is the remaining. Remaining is the maximum. Now my question is, what is the minimum kinetic energy? Next. 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 Zero. Minimum kinetic energy is 0. Why minimum kinetic energy is 0? Because whatever you are sending, that is equal to the work function, the electron is not having sufficient kinetic energy to move. Am I right or? So that's why whenever whatever the incident energy is equal to work function, then the kinetic energy is 0. That's it. So always electron is having kinetic energy range from where to where? 0 to Ke max. What is this Ke max? H nu minus H nu. Clear? Right. Next one. Second point. So finally, what is the photoelectric effect equation? Ke max equal to H nu minus. Good. Ke maximum equal to H nu minus H nu. We can write it as a H nu minus nu naught. Now I want to find a velocity from that equation. How we will find? Read that expression. Read this expression. I want velocity maximum. How can I get? Read again. Here you can't answer anything. Kinetic energy maximum equal to half mv max square. This was the just question. So this V max equal to, so I think this can be written as a 2 h nu minus nu naught by m. That's it. So the maximum velocity of the electron which is coming out of that surface is nothing but this one, under root 2h nu minus nu naught by. After that I will explain one beautiful question. Come on, write down. Don't simply copy, don't simply copy. So I hope everybody understand here why the kinetic energy is having a range. So because this is the sending and some energy is a minimum is required to bring the electron out because it is already bound electron to this metal. Okay. So if the electron wants to come out, you need to supply some minimum energy. That minimum energy is a phi. That's why whatever you are sending, you subtracted that minimum. Whatever the remaining is given as the kinetic energy of the electron, that electron is coming out with that kinetic energy. But that is the maximum possible kinetic energy. If anybody asks what is the range of kinetic energy of the electron, you can say 0 to some maximum value. Ready? Write the problem. Okay, I will explain the problem. Listen. Now this was the question given in just exam. It's a beautiful question. See how they are framing the question. See. Now here they have given a metal plate whose work function is phi. And we are sending the incident light with frequency nu. That's why what is its energy? H in nu. And this electron is coming out as usual with some kinetic energy. Now what they have given? Right. Now this electron is coming out with some kinetic energy. Now what they have done? They applied the magnetic field perpendicular to like this. So what is this? For example, electron is coming out like this perpendicular. This is the perpendicular magnetic field to the motion of the electron. This is what they have given in the question. Now then they ask, this electron will make a trajectory like this. Then what is the radius of that trajectory? Question is photoelectric effect, but linked with the magnetic field. So if a student wants to answer this question, they have an idea of photoelectric effect first. Next, magnetic field, motion of a charged particle in magnetic field. See, solving a problem in the physics is always you have to bring the concepts and you combine and apply to the problem. It never be framed on a single concept, it is framed on multiple concepts. This is the best example how they will frame a question. Everybody know photoelectric effect. Everybody know what is the kinetic energy. What is the kinetic energy of electron? H nu minus H nu naught or phi, whatever it is. But how, see how they are framing the question. Now I applied the magnetic field perpendicular to the motion of the electron. Perpendicular to the motion of the electron. Direction of motion of electron. And then it is making a circular path. Then what is the radius of that circular path? Everybody understand the task? So if you want to understand this, if you want to solve this, you need two concepts. One is photoelectric effect. First one, photoelectric effect. What is the photoelectric effect equation? Already we have seen. Come on, say Ke of electron equal to h nu minus phi. No. Listen. Whenever you are solving the problem of physics, your answer must be always in terms of given quantities. They didn't say about nu naught. They explain only phi. So your answer also must be in terms of phi. Please remember this. You should not take any other variables, other quantities which is not described in the question. Your answer always must be in terms of the given quantities in the question. Clear? Sir, work function h nu naught. H nu naught for us. For the paper setter who is asking the question, for him it's not. It's a work function phi only. So that's why your answer also must be in terms of phi. Good. So that's the kinetic energy. And the second part, this is motion of charge in a magnetic field. Wait. Just a few minutes back, we have discussed a charged particle in the electric field. What that electric field will do? Accelerate. But what magnetic field will do? It won't accelerate. What it will do? Turn. Electric field will accelerate. Magnetic field will turn. If you go through that bridge course of physics last class, the motion of a charged particle in electric and magnetic fields. Maybe till, I think you didn't come up to that class, I think. Okay. Anyhow, right. So for example, here is the charged particle Q, which is moving with velocity v, and I applied the perpendicular magnetic field. The charged particle is moving like this. I applied the magnetic field into the board. Okay, right? Understand? Charged particle is moving like this, and this is the magnetic field. Then what will happen? It make a circular track of radius r. Why? Listen. Now I hope everybody know what is the magnetic force on this charged particle. Could you please tell me what is the magnetic force? Very good. The magnetic force is nothing but Q V bar cross V bar. Q V bar cross V bar. Let me write here. But velocity and magnetic field both are in perpendicular direction. That's why this is a sin 90 equal to 1. So how much amma? Q. Now, for example, here, I hope you know, one minute. For example, now I want to make a circular path. I want to move in a circular path. What I need? Centripetal force. If you have a nucleus here, the electron is revolving around the nucleus. According to Bohr, it is a circular orbit. According to Sommerfeld, it is an elliptical orbit. So according to Bohr, it is moving in a circular orbit means, how that electron will move in circular orbit? Because someone is supplying necessary centripetal force. Who is that? Coulombic force. There is a Coulombic force between the nucleus and the electron. That Coulombic force is giving the electron sufficient centripetal force. That's why I don't know how many of you remember in intermediate, in the hydrogen atom, the first step what you have solved, Coulombic force is equal to centripetal force. mv square by r is equal to ze square by 4 pi epsilon naught r square. This is the first step we have written in the Bohr's model. Because that force, both forces are balanced. Then only it will it will move in a circular path. So similarly, if you want to make a circular path, you need a centripetal force. I hope everybody know what is the centripetal force. What is the centripetal force? mv square by r. Now see. So this centripetal force is supplied by magnetic field, magnetic force. Yes or no? Yes. That's why this F magnetic is equal to centripetal force. How much it is? So finally, what is the magnetic force, ma? QVB equal to mv square by r. VV gets what he's asking. Radius equal to mv by. No need to read this. When I ask a question, then say that is enough. I know. Okay. mv by qb. Right? So this is the concept of magnetic field and charged particle. So from this concept, what you get? Radius of the electron equal to mv by qb. Now take this and apply to photoelectric effect. In photoelectric effect, what you are getting? Kinetic energy is equal to kinetic energy of the electron in photoelectric effect equal to h nu minus. What is the kinetic energy? Equal to. Now what you will do? One more time, the question is simple. So the electrons are coming out from this metal surface and a magnetic field is applied perpendicular to the direction of motion. Then they are asking what is the radius of that circular path. So the concepts involve two concepts. One is the photoelectric effect, another is the motion of charged particle in a magnetic field. So here I explained that motion of charged particle in the magnetic field. So if any charged particle or any particle wants to make a circular path, it needs centripetal force. That centripetal force is supplied by magnetic force. That's why both are equal and we got the radius. But still it is incomplete because what is the velocity we don't know. Because in the question velocity is not mentioned. See all of you. Sir, why I have to substitute velocity, sir? I got the answer radius equal to mv by qb. Just now I said one thing. Always your answer must be in terms of given quantities in the question. What is given? H nu given. What is given? Phi given. So that's why your answer must be in terms of that only. So then immediately what you have to convert velocity. We have to change that velocity term. But slowly get the habit of solving the problem. Don't get tension. So whenever you are reading the question, you have to develop one picture in your mind. See, the question is given in the sentences, but here I have drawn a diagram. So like that we have to imagine. This is the primary basic way of solving the question, solving the problem in physics is just imagine a diagram. Imagine whatever they are explaining, you just represent that in the diagram form, then automatically you will get the concepts. Tension madakandi, problems emi more difficult and feel avuddu, no need to feel. Okay, so these are basic questions. Whenever we are doing the work for first time, you feel difficult, but the same work is doing after 100th time, it will be dead easy, definitely. So just keep on doing again and again, definitely you feel easy. Right, ready? By seeing that question, you please say the question. By seeing that, sorry, by seeing the diagram, you please try to develop the question. Why I am saying like that? Listen, reverse way. Actually, question is given, what I told you, you have to imagine the diagram. So how you will get that? Reverse. Now diagram I have given, you please try to develop the question from that.
Frequency nu is incident on a metal surface having Planck function phi. Electrons are ejected and a magnetic field is applied perpendicular to the direction of electric field. Then find the radius of the circular path, radius of the path followed by the electron.
Good. Find the radius of the trajectory if it makes circular path. Definitely circular path. Why circular path? Magnetic field is perpendicular to the velocity. If the magnetic field is applied perpendicular to the velocity, always it makes a circular. Good, very good. That's it. Simple. Fine, very nice. Huh? Right. Ready. Next one. Okay. So again, here I am going back to this discharge tube. All of you please listen. This is also quite interesting one. Right. So I told you already, this is my target, okay, and here we are sending. So one more time I am saying, whenever you are solving the physics problem, initially it takes so much time, but just keep on try. Don't ever expect the same questions you will get in the exam. Impossible. Okay. Then only one person can handle the coachings. Who is that? If anybody, paper setter. Okay, so this is the negative, okay, and this is the positive polarity, okay. So right, this is plus, minus, something like this. This is very interesting. Listen, listen, because till 2 days back you don't have the habit of listening properly. Okay, that's why initially it is very difficult to concentrate. Andre ide em class adi. Listen. So let us suppose this is a Vs and this is a minus and a plus. Cool. Please observe. Now here we have a negative terminal and this is the positive terminal. What is your electric field direction now? Positive to negative. Positive to negative. Okay. Right. So, okay, leave it. Now the electrons are ejected. 1 minute, Amma. Let me check. Right. The electrons are ejected. So the electron is ejected, and where it will be collected? Here. So electron must come to this plate and accumulate. Say yes or no? Yes. Right. So how this electron will come? That means what I am saying is, how much potential you applied here? Vs. How much potential applied? Vs. If the electron wants to come from this point to this point, how much potential difference you applied one more time? Vs. If Vs is the potential, how much energy is there? EVs. Try to understand, very important. Now this electron wants to come from this location to this location, what it is having already? That kinetic energy must be equal to EVS. I don't know how many of you understand this point. One more time. Actually, you send a photon of energy h nu, and this is having some work function, and electron is released. Electron wants to reach from this plate to this plate. It needs some kinetic energy. That kinetic energy must be equal to EVS. Because how much potential you applied, ma? One more time. Okay, leave it. You didn't understand. I hope so. For example, listen. This is the point where I have the potential V1. This is V2. Okay. Now the electron is here. The electron is going from V1 to V2. How much work should be done? E into delta V. Ninth class, amma. Q into V is nothing but work done by the charge, work done on the charged particle. If a charged particle Q is moving from one potential point to another potential region, the work done on the charged particle is equal to Q into potential difference. Say yes or no? Yes. Listen. Here is the charged particle, okay, and this is the potential V1 and this is the potential V2. The charged particle is moving from this location to this location. Then the work done is nothing but a Q into delta. Ninth class untundamma text physics book. Right? Or V1 minus V2, whatever it is, some difference. Okay. Right. So this is the amount of work done. Amount of work done is stored in the form of energy. Maybe potential energy, maybe kinetic energy. Here that is stored in the form of. Once again, this is the metal plate. Electron is released and it is going towards the other plate and be collected there. So if it wants to move from this plate to this plate, how much kinetic energy it need? Kinetic energy must be equal to charge into potential difference. Say yes or no? Yes. What is the potential difference here? Yes. So how much work is done on the charged particle? Yes. That work done must be equal to? Yes. That's it. So kinetic energy of electron must be equal to EV. Yes. Wait, what is this Vs? Stopping potential. What is that? Stopping potential. So what is that stopping potential? The potential required to stop the most energetic electron. Simple common sense, amma. For example, here zero potential, their potential is V, let us suppose. Now I am going from here to here or here to here, whatever it is. Then what is the work done? QV. Now I have that much kinetic energy. Now how much kinetic energy I have? QV. Now I am moving with kinetic energy QV. Now you want to stop me. Then how much potential you will apply? V. Q and how much potential you apply? V. But you will apply the reverse potential because you are stopping me. Understand? So that's why this is the negative terminal and this is the reverse stopping potential. So kinetic energy must be equal to EVS. Kinetic energy already we got the formula. Could you please tell me how much it is? Very important. Kinetic energy of the electron equal to, already we know one more formula, kinetic energy equal to h nu minus h. Is it right? Come on. Once again tell me what is the stopping potential definition? The potential required to stop. Why it is most energetic electron? Maximum. Your kinetic energy, electron kinetic energy is already maximum. If you are stopping that maximum kinetic energy electron, that's why this is called stopping potential. the potential required to stop the most energetic electron. One minute, I'm just refreshing, just don't get tension. So, still if anybody didn't understand, the electron is ejected, but if it wants to move from this point to this point, it needs some kinetic energy. How much kinetic energy is required? Here you have applied some negative potential here, so that's why it has to overcome from that potential. So that's why it need kinetic energy which is exactly equal to QV. Here Q is nothing but the charge and V is the potential. So that's why in the textbooks they will write kinetic energy is equal to EVS. Why they will write like this? Because whatever the electron is ejected, it has to reach to this potential, so it need to do some work. That work is nothing but kinetic energy. So that work done and kinetic energy must be equal. Simple. If I want to go from this place to that place, what I need? Kinetic energy. Without that, if I say stay here, if I say some mantras, I will go there. No, it's not possible. Okay. So we need some kinetic energy. Right. Ready? Is it over? Once again, this is the kinetic energy equation, everyone see. So what is the kinetic energy equation? H nu minus H nu. But that kinetic energy must be equal to EVL. Why? Because, so whatever the kinetic energy of the electron, so that is nothing but the work done to go from one point to another point. That work done is nothing but charge into potential difference, that is EVS, because we applied here. So that kinetic energy must be equal to EVS. Everybody got the clarity? Right. Now ready. Amma, this is also interesting. So here I have kinetic energy equal to of electron, nothing but this is a H nu minus H nu naught. All of you please listen. Now here I have taken a graph, Bob important. This is the frequency and this is the kinetic energy I have taken. Read the expression. Ke equal to y-axis, x-axis. Draw the graph. Try in the rough page and show me. No. First do it in the rough page and show me. Anybody? Keep one rough paper always. Just I am asking the graph of this equation. Kinetic energy equal to h nu minus. Right, listen. In 10th class, you have studied straight line equation y equal to mx plus c. Here y-axis is nothing but the kinetic energy, which is nothing but h nu. Your x-axis is nothing but nu. And after that, what you have minus h nu naught. Could you please tell me what is this c? Y-intercept. Your y-intercept is negative or positive? So your straight line is intercepting the y-axis at negative side or positive side? Okay, so that's it. And could you please tell me what is this? Work function. What is this? Work function. This work function phi is nothing but what? H nu. What is this? What is the theta? Or what is the slope of this line? Slope of a line is tan theta. Now tell me, what is the slope of this line? Slope means tan theta. Tan theta equal to what? Slope. Slope of that line. Next. What is the slope of this line? You understand how we drawn this line? It's a straight line, not passing through origin, making intercept along, making intercept y-axis at a negative point. That is what we have done. And then this line is making some slope. The slope is nothing but tan theta. Now I am asking, what is that slope? Some people won't think anything. Some people will simply sit there. But please observe the board. Answer is in the board only. Next, what is the slope of this line? H, Planck's constant. Now tell me, this is the question. The slope of, not CSR question, the slope of kinetic energy versus frequency graph. Planck's constant. Which of the following is the slope of a graph between kinetic energy and frequency? Kinetic energy and frequency graph, what is the slope? So tan theta is nothing but h. Like this they will ask the questions, maybe for set exams or something like that. Okay, next wait. Second one, at least you please do this. Earlier one more thing I told you, kinetic energy is nothing but EVS, which is nothing but again h nu minus h nu. Now I am taking this Vs, h nu minus h nu naught by E by E. Now draw this graph. This is a nu and this is the stopping potential. Now tell me what is the slope of this graph? Slope h by, because y equal to mx plus c, everything including subject also. So this is the theta and here the tan theta equal to h by. So whenever, see, questions are quite similar, okay, but we will remember this. In the option there is a h is there, h by e is there. We will answer h and we will come out and we will say I answered the question, but we won't see this. Always you have to be very careful whether they are asking kinetic energy versus frequency, yeah? Stopping potential versus frequency. The work function kaadamma, stopping potential. If it is a stopping potential versus frequency, the slope is. If it is a kinetic energy versus frequency, clear? Observation is very important. That's why I'm explaining these type of questions in the beginning. A small observation. If you miss that observation, you will get wrong answer. Don't copy, don't copy. Again, if you are copying means you don't know that 10th class base. So just y equal to mx plus c, nothing else. Here the intercept is a work function, but here the intercept is a work function by E. That's it. And the last one more point. With that, photoelectric effect is end. Kinetic energy is dependent on intensity or independent of intensity. So whatever may be the intensity, kinetic energy is always same. But now today I explained kinetic energy is equal to something today. EVS. Kinetic energy equal to EVS. Now tell me, although intensities are different, what is same? Stopping potential is the same. See, different way. Because whatever may be the intensity, kinetic energy is same. But what is the kinetic energy of electron? EVS. The EVO, EVS, or whatever it is EV. So like that. Ready? Yeah? For example, the question is like this. Which of the following is the same, remains the same if we increase the intensity of light? Sir said kinetic energy, but in the options kinetic energy is not there. In the options there is Vs. But you know na, kinetic energy is equal to EV. Okay. So the last one, I hope everybody know this, just I am concluding ma. So here I'm using a different intensities. Here I have number of photoelectrons, or we can say current, photoelectric current. Why current? Current is nothing but rate of flow of charge. Right? I am taking this intensity I1, I am taking this intensity I2. Let us say I2 is greater than I1. Although intensities are same, kinetic energy remains same. But kinetic energy is nothing but EVS. That's why that Vs is a negative potential or positive potential. In the textbooks, the graph will be like this. They won't represent with kinetic energy. They represent with Vs. Different intensities, stopping potential is same. But that stopping potential means EVS is nothing but kinetic energy. That's why different intensities are having a same kinetic energy or same stopping potential. Clear? That's it. Conclude. stopping potential is same. Why? Kinetic energy is the same. Maybe you won't remember again. Please write here like this. That's it. This is the end of photoelectric effect. See, I didn't simply draw the graphs because I asked you and we have given us a question like that, we drawn all the graphs. I don't want to simply give the notes, draw the graphs and you will write, so no use. You should know why it is like this, why they have drawn the graphs like this, what is the reason behind that. I hope everybody understand. Okay, so over. Once again recap what we have discussed today. Started from here, right? Right. So what we have explained here. I think this concept is, maybe if anybody don't know, please remember. Electric field will accelerate the charged particle. Magnetic field won't accelerate. The reason is magnetic field won't do any work on the charged particle. Say yes or no? Right. Because Q force is equal to Q V bar cross B bar. Okay. So and I hope you know that dot product is equal to what? 0. Work done is equal to F bar dot S bar, that dot product equal to 0. Okay, leave it. Only electric field will do the work. Magnetic field won't do any work. Right. That is what I explained. And all positive charged particles will move in the direction of electric field. Negative charged particle will move opposite to the direction of magnetic electric field. Sorry, electric field. Next, come to this. What I explained. If the light falls on the metal surface, immediately electron won't come out. Electron wait. So you have to send the minimum amount of energy. First you must satisfy the electron. So the electron will get that minimum amount of energy, then it ready to jump out of that. So till then it will be there in the well only. It's a taking rest. Okay. So once you have given that minimum amount of energy, electron is ready to come out. That means just to come out. The amount of energy required to bring the electron out of that surface is nothing but a work function. That is what I explained in the first. One more time if anybody didn't listen properly. And here I have given the work function definition. H nu naught, threshold frequency, Hc by lambda naught, threshold wavelength. And to explain this, I have taken this example. Maybe you know the energy of a photon is nothing but h nu, which is a Hc by lambda, which is 12,400 by lambda in angstroms, and a nanometer 1240 by lambda in nanometer. Right. Now try to say the answers, because whether you remember or not, by seeing your answers, by listening your answers, I will understand. Next, just a given example, that's it. And after that, yeah, this is a beautiful question. So, the energy of the photon corresponding to the Compton wavelength is nothing but the rest mass energy of electron. So, completely different particles, okay, but whenever you have the electron as a target and if you are sending the X-ray photon, in the Compton effect we are getting Compton shift as a 0.0242 angstroms. That is called Compton wavelength. If that Compton wavelength is there, it is related to the energy of the rest mass energy of the electron. That is what we have taken. And after that, so we are concluding the photoelectric effect. So final photoelectric effect equation is given. If anybody asks what is photoelectric effect, don't say Ke equal to h nu minus h nu naught. In always interviews, we should not say the equations. We have to say the sentences. what is a photoelectric effect equation చెప్తాను oh ఇదేదో by heart by maybe by hearted or something like that they will get it out. Always our answer must be in terms of statements, not in terms of formulae, not in terms of equations, right? That's it. That is what we have taken. Kinetic energy is nothing but a remaining or output. Output is equal to input minus a spending. That is what we have done. And here we find the maximum velocity, and after that a beautiful question we have taken. So here consider a photon of a frequency nu is incidenting on the metal surface of work function phi, and the electron is ejected, and a uniform magnetic field is applied perpendicular to the motion of the electron. Then it means making a circular path, and what is its radius. That is what we have done. It's a beautiful thing, and we have explained these two concepts. And after that this one, stopping potential. What is this stopping potential? Now the electron is released at this location. Now it will be collected there, so it has to move from here to here. For that it needs some kinetic energy. That kinetic energy is nothing but work done. What is that work done? Charge into potential. The simple concept. It needs kinetic energy. That kinetic energy means nothing but a work done. That work done is nothing but charge into potential. That is what we have done. And from this we got the kinetic energy is equal to EVL, where Vs is the stopping potential. That stopping potential means the potential required to stop the most energetic electron. That's it. And after that these graphs. So we have taken two equations and we have drawn just it's a y equal to mx plus c. No need to get tension. Okay, so from that we explained here the slope is a Planck's constant, here the slope is a h by e. That's it. And finally the conclusion. Different intensities have different kinetic energy. Sorry, same kinetic energy. But in the textbook they won't represent kinetic energy, they represent stopping potential. That's it. Why I told you what is the reason. This is what we have discussed. Right? So take a break and